Good morning to one and all. So today we are going to discuss about logical connectivities and truth table. So here we are going to discuss about negative distinction. Distinction is nothing but or, exclusive distinction, and conditional, biconditional. These things we are going to discuss in logic connectivities and truth table. So if you observe the definition, new propositions are obtained by starting with a given proposition with the aid of words or fors like not, and, if, then, and if and only if. Such words or such paras are called logical connectivities. In a sense, if you are connecting with these words like not, and, if, then, if and only if, these type of words are connected with your given alphabets or something, we call it as a logical connectivities. The new propositions obtained by the use of connectivities are called compound propositions. So up to this we know that. So we start with the negation. See, in the negation, a proposition obtained by inserting the word not at an appropriate place in a given proposition is called the negation of the given proposition. So in the sense, if you add a not before the letter, we start it as a negation. The negation symbol comes like this, not. So this symbol we call it as a not P. It means that so it is a negation of P. So not P is the negation of P. If you consider this table, so here we are having some truth table. Initially they given P values. P value is 0 as well as 1. If you want to write the truth table for negation for this, first you have to put not P. It is opposite to your P value. If it is P is 0, in the sense fail, it should be negation of P should be pass. It should be 0, means it should be 1. If P is pass, in the sense 1, P negation P is fail, in the sense 0. Like this negation will work. Next is conjunction. So conjunction, in the sense, here you have two elements. So those elements having some possibilities of inputs, in the sense, if you combine these two P and Q, you can be able to see both should be fail condition or both should be 0. Instead of fail and pass, we are using zeros and 1. Fail means 0, pass means 1. So if we combine P and Q, we can be able to see 4 type of condition. What are the 4 type of condition? First condition, both should be in 0 state. One Q should be in 1 state and P should be in 0 state. The next is P should be in 1 state and Q should be in 0 state. P and Q both should be in 1 state. So conjunction, in the sense, so once you are writing the conjunction, you are combining these two elements. If both should be pass, then only it should be pass. Remaining all condition, it should be fail. In the sense, both elements value is present as 1, then only your output value is 1. If any one element value belongs to 0, your output definitely it should be belongs to 0 only. You just observe here P and P conjunction Q, in the sense both should be what? Both should be 1, then only your value should be 1. You observe here both are 0, so it is also 0. In this case, one statement is 0, so output is 0. Here one statement is 0, output is 0. Here both statement are 1, so output is 1. Fine. This is conjunction. Conjunction we also call it as OR. So sorry, AND. Conjunction we also call it as a AND, in the sense both should be in positive, then only output is positive. Remaining all times it should be in negative. Okay. Next is disjunction. Disjunction is nothing but OR condition. Here you just observe in the disjunction. So in this disjunction you should observe here. So P and Q, both elements having 4 possibilities of input. In these 4 possibilities of input, if you are writing a disjunction, the disjunction symbol is P disjunction Q, like this manner. So here if any one element belongs to 1, the output belongs to 1. If any 2 elements are belongs to 0, then only it is 0. Remaining, if P or if Q, any one element, if 1 is present, the definitely output is belongs to 1 only. You just observe. P is also 0, Q is also 0. P disjunction Q is 0. But remaining all state, it should be 1, 1, 1. So that is your disjunction. Next is biconditional. Okay, come here. Before that, we go for, sorry, it is repeated. Wait. Next is exclusive disjunction. In this exclusive disjunction, what happened? You observe properly. The symbol is disjunction below that one dash symbol. So this we call it as a P exclusive disjunction Q. Here you just observe properly. Here any one element should be 1 and remaining is 0. Then only output is 1. If any one element should be 1 and remaining should be 0. You are observed here 0 0 output is 0. 0 1 output is 1. 1 0 output is 1, but when comes to the 1 1 output is 0. Both elements should not be, P and Q element should not be same. It should be different element. Then only the output belongs to 1. Here you observe P is 0, Q is 1. Both elements are different. That's why output is 1. Here you observe P is 1, Q is 0. Both elements are different. That's why output is 1. So this mechanism we call it as a exclusive disjunction. Next we go for the conditional. How it is work? For example, if you observe here P and Q, okay, here if P is 1, Q is 0, that input, so P is having a 1 element and Q is 0, so that time P implies Q, in the sense 1 implies 0, that time output is 0. Remaining all cases the output belongs to 1. This we call it as a conditional statement. Observe properly. So P implies Q, in the sense 1 implies 0, that time only your output is 0. Remaining all time your output belongs to 1. If the same condition in the reverse manner, 0 implies 1, definitely the output is 1. Your only condition is 1 implies 0, that time your output 0. Remaining all condition your output belongs to 1.